Hi, I'm Michaela, this is Matt, and this is JP, and we're SmartSpace. So first, I want to begin by introducing the problem we're trying to solve. Students waste a ton of time trying to find a place to study on campus. And that's because in order to know if a space is available, you actually have to physically go and look, leading to a lot of time just spent wandering. We experienced this to be a problem in our daily lives, so we surveyed students to see if they felt this pain point as well. It turns out they do. In fact, for the entire student body, over the course of the school year, students collectively waste nearly 1 million hours trying to find a place to study. So this is a pretty big problem. But before we figured out our solution, we wanted to understand who our stakeholders were so that we could design a product around their needs. So we identified 3 key stakeholder groups: students, facilities personnel, and the university. We included facilities personnel because we anticipated having a hardware component that they would have to interact with. So regarding needs for students, their first need is the ability to check for available study spaces from a remote location. And secondly, any hardware component that we introduce can't be invasive to their study space. This hardware component also needs to be very easy to maintain and handle for the facilities personnel. And lastly, the university is currently making investment decisions in an information-impoverished environment. Data showing demand for certain types of study spaces and studying habits and preferences would be incredibly valuable in helping to determine where and how to allocate resources. So given our stakeholders and their needs, we designed SmartSpace, which Matt is going to discuss in further detail.
Thanks, Kayla. So as you can see here, this is the overall design for our project. However, we can simplify this by focusing in on 3 main components: the Internet of Things sensor network, the web app, and the data. So first, I would like to talk about the sensor network in a bit more detail. So our sensors are powered by an Arduino MKR1000, which is an ideal board for Internet of Things projects due to its built-in Wi-Fi connectivity. The Arduino powers an infrared sensor, which measures distance to determine whether or not the study space is occupied. Next, a crucial part to our hardware design is this RFID reader, which allows our sensors to be placed in any study location. So for example, if a sensor is about to die, a facilities person can go in, put it in the charging station, and replace it with any other sensor, which will then read the RFID tag on that study spot and know exactly where it was just placed. Next, there's an LED just to show us whether or not the sensor is paired and working correctly. And then finally, there's the battery, which can be wirelessly charged via this QI receiver on the bottom here. So all of this is encased in a 3D printed housing, which has our logo and our website engraved on top of it, as you can see here. So in terms of alternative designs, we considered several other sensors, such as load and vibration sensors, on the desk, under the desk, and on the chairs. But we determined that the IR sensor on top of the desk was the best solution. One reason for this is that, say for example, a student goes to the bathroom, or they go get food and they leave their stuff on their desk, we don't want the web app to update and say that that spot is available, because it's not. So having the IR sensor on top of the desk allows it to see not only if you are there studying, but also if you are reserving the spot with your stuff, which tends to happen quite often. We also considered other alternatives, such as having sensors simply at the entrance to each room and counting how many people are walking in and out. But we determined that this solution isn't ideal because it would not be able to show which individual study spots are available, which we thought was very important. So now that I've gone over the hardware, I would like to pass it back to Kayla to discuss the software.
Thanks, Matt. So our web app is written in Ruby on Rails and also incorporates a JavaScript library for some of the front-end UI. We chose Ruby on Rails for one of its really popular, well-known features, which is association tables, which allows you to create relations between objects. For example, a building has many rooms, which has many study spots, and a study spot belongs to a room. This made it really easy for us to keep track of and manage all of our study spots in our database. Here's an example of the front-end UI for one of our study spaces. This is actually Detkin Lab, which you'll see later today, and we have the occupied seats marked in gray. And now I'm going to hand it off to JP to go into a little bit more detail about our data.
Thank you, Kayla. Now, we can extract a lot more value for both our students and the university by collecting data for them. So how can we actually use this data? Well, first off, students often need to be able to plan their schedules far in advance as opposed to just at the current moment. So by collecting data for them, we're able to provide them with information like the probability that a given seat is open at any given point during the week. So for example, if a student could go online and see that Huntsman is really busy on a Saturday morning, but Van Pelt is not, then they can schedule their Saturday day around studying at VP in the morning. As for the university, as Kayla had mentioned beforehand, they need to take money and invest in constructing new study spaces for students or enhancing existing ones. So, by providing them data on students' study habits and location preferences, they're able to make much more informed decisions in terms of resource allocation. So, in order to gather some example data, we set up 5 of our sensors in the Deccan lab and allowed them to run for a week. Here's an example plot of the data that we collected, which displays the expected number of seats occupied by each hour of the day on a given Friday in the Deccan lab. So, if I were a student looking to study by myself, I can see that between the hours of 2 a.m. and 7 p.m., it's an ideal place for me to study, but after that, it might be a little too loud and noisy for me to get my work done. Here we show another plot which displays the probability of at least 3 seats being open versus every single hour of the week. This information will be vital to, let's say, a group project team that's looking to schedule their group project day. And they go and they schedule on a given Sunday, only to go down and actually find that there's no space for them to actually work. So, given all of this, where do we actually go from here? What are the next steps for our products? So, first off, we'd like to take advantage of some aspects of machine learning so that we can provide recommendations to students based off of their previous study habits. Secondly, we'd like to take advantage of app and user analytics, and by that I mean, where are students actually going on the website and clicking? Which room are they looking to check out first? If that room is full, which room do they check out second? What's their third preference? Just knowing the occupancy state of a given seat doesn't really paint the full picture behind a given room. So for example, if we have 2 rooms, like room X and room Y, that both have very similar occupancy levels, we can determine that students always click on room X before room Y, then obviously there's a far greater demand for that room. And lastly, we'd like to scale up our solution to provide sensors on every single study space possible on the campus. And then in doing that, we would try to manufacture overseas and buy in bulk in order to drive our costs way down. So obviously we'd like to implement our solution here at Penn, but our solution can be extracted to many other practical applications like public transportation, restaurants, parking garages. The possibilities are seemingly endless for us. We'd like to thank you guys for coming out today and listening to SmartSpace and our products. And we'd also like to thank our advisors, SWAP, our professors, Sid and Jan, and our TAs, Jeff and Catherine, for guiding us throughout this process. Thank you.